Okay, so to finish this up, this unit on trig. So what have we done in this unit? Well, we basically did some stuff to help us prepare how to find trig ratios exactly using the unit circle. That was last lesson. And then learn some stuff that's going to help us do this one, solve trig equations. Okay, and then we added a couple other things in there too, like we learned about a new angle measure called radians and how to convert between degrees and radians. We learned a new formula about how to calculate an arc length in a circle and use that to solve problems. Okay, so, but the big ones of this unit were lessons 3.4 and 4.4 and this one. So before I go on to that, so this would be what we did in the last lesson, although we did more complicated expressions. Like if I said this, tell me that. I hear it. I hear it. I thought I heard it. Somebody was saying it. Negative root 2 over 2 because we use the unit circle. Here's pi over 4 in the middle. Okay. Here's 3 pi over 4. Here's 5 pi over 4. What are the points there? Negative root 2 comma negative root 2. And cos tells us to take the x, although sine of this would be the same thing anyway. So yeah, negative root 2 over 2. What we're doing today is this. You're given the trig, you're given the answer, but you're asked to find the angle. So basically, I want to know what angle or angles, because there could be more than one answer, is the cos of 1/2. Well, we can use a unit circle. Where is cos 1/2? Up here? Yes? And down here? Right? So what's the angle there? 60 degrees, or what in radians? It's okay, you can cheat. Pi over 3. I know, it's not like you spent the holidays reading the unit circle. Okay. How about this one? This would be 5 pi over 3, or in degrees, 300. Okay. All right. So you guys just solve a trig equation like this. Okay. And you could be asked to answer in degrees, or you could be asked to answer in radians. Usually, you will be asked radians now. And how do you know which one? Well, look for the notation. If it says this, you got to answer in degrees. If it says this, you got to answer in radians. To start, we're going to answer in both. Okay, but you won't be expected to answer in both. It'll give you one or the other, usually radians. Well, if the answer to the trig equation, the angles that we're trying to find, if the answer is on the unit circle, it's one of the values, we don't have to do any calculator work. We just use the unit circle. And 1/2, well, that's a unit circle value. So I can use my knowledge of the unit circle to find the missing angles. And basically, I ask myself this. what angles have a y coordinate, because it's sine, of 1/2 on the unit circle? So if you go to your unit circle and y is 1/2 at 30 degrees and 150. So that would be the answer in degrees. 30 degrees. The sine of 30 is 1/2, but also 150 degrees. Okay, because if you think of your unit circle, 1/2, well, here's a point where y is 1/2 at this angle. And here's a point where y is 1/2 at that angle. So that's 30 degrees, and that's 150. What would they be in radians? Pi over 6 and 5 pi over 6. But what if the point is not on the unit circle? Like this one. 0.3 is the same as 3/10. That is not a value on the unit circle, which means we can't use the unit circle and answer it sort of mentally without having to do any work. We're going to have to use a calculator. And we reviewed this last year, and I'll review it again this year. What we do I just sort of call it quadrants reference angle. That's the method. And you're going to have to use a calculator to get there. Okay. First of all, so remember, you're trying to find a missing angle or missing angles. First thing I'm going to do is figure out what quadrants are the missing angles in. Well, to find the quadrants, I am looking for what quadrants cos is a positive number. In what quadrants is cos positive? That's where you got to think of the all snake stock crab.
1 and 4.
1 and 4. So I know my angles are going to be there. The question is, what are the specific angles? And this is where I use a reference angle. How do you find a reference angle? You do the inverse trig of the value you're given. And it always has to be positive. So if this is negative, when you find the reference angle, make this positive before you find it. This one's already positive, so I don't have to change it. That's going to give me the reference angle. And this is where you got to use your calculator. And let's start with degrees. So first off, you got to make sure your calculator is in degree mode and not in radian mode. There should be on your display a D somewhere, or DEG. If it says that, you should be in degree mode. If it says R or RAD, you're in radian mode and you have to switch. So on this, just go to mode and you're probably in radian. If you look at the third one down. Oh, you're in degree, okay. Because usually it defaults. So we'll go to degree. So you're fine. And so then what we want to do is take the inverse cos of 0.3 and let's go 3 decimal places. Get used to that. So inverse cos of 0.3, 72.542 degrees. Now we're ready to find the actual angles, because now I know everything I need to. I know one of the angles in quadrant 1, and the reference angle is 72.542. What's the actual angle in quadrant 1? Same thing, 72.542 degrees. That's quadrant 1. In quadrant 4, how do I find the actual angle? 360 minus the reference angle. So 360 minus 72.542, 287.458 degrees. So these are your two answers. But what if you were asked to answer in radians? Because we have to do both in this. Well, this is the same. The quadrants are still the same, but this is going to give you a different answer because it's not going to give you the answer in degrees. It's going to give you the answer in radians. So what you need to do is you need to change your calculator to radians. Okay, so that's degrees. So if we do radians, cos is still positive in quadrants 1 and 4. Now to do my reference angle, I still do the cos inverse of 0.3. That's going to give me my reference angle. But it's going to give me a different value because I'm in radians. And 1.266. And remember, you don't have to put units for radians. Okay. So now I'm ready to find my answers. Well, in quadrant 1, the actual angle is going to be the same as the reference angle. So 1.266. That's one of my answers. Now remember, you've got to change your thinking to radians. It's not 360 minus now. What's a complete circle in radians? It's 2 pi minus the reference angle. And if you have to do 180 degrees, like if you're finding an angle in quadrant 2 or 3, you use pi instead of 180. So here, all I do on my calculator is just 2 pi minus 1.266, and you should get 5.017. And those are your two answers in radians. Like I said, we're going to focus mostly on radians. And these mean the same thing, they're just different. Like 72-degree angle is about 1.3 radians. 287.5 degree angle is about 5 radians. Anybody still need it?
Can I also just multiply with?
Yes. Okay. So I just wanted to show you how we work on a calculator in degrees and in radians. But now these questions are going to be, it's either going to be radians or degrees. It's not going to be both. Radians or degrees in this one. How can you tell it's radians? What gives it away? The 2 pi. If it was degrees, this would say 360. Okay? But because it says 2 pi, that's radians. Well, before we can solve it, we need to get sine theta by itself. Just like when we solve for x, we need to get x by itself. So I subtract 1 from both sides, and I get 2 sine theta is equal to -1. Divide both sides by 2, and my equation that I'm going to solve is that. Do I need to use a calculator, or can I use the unit circle? Unit circle, because it's a half. And well, it's negative a half, but it's still a half. So this is a unit circle value. I'll just put that for short, UCV. Which means I don't have to go through all that calculator work. So, thinking of my unit circle, I am looking for the points where y, because it's sine, is -1/2. That would be here and here. And those ones close to the x-axis, those are the pi/6s. So which ones are these? This one is? I can't hear. 7 pi/6, correct? 11 pi/6, correct. That's it, you're done. These ones. Well, they're going to be, these are all going to be unit circle values. Because if you look at them all, or sorry, one of them is not going to be. Which one? F. Because 3 is not a unit circle value. But A, B, C, D, E is. So again, use your unit circle. Where sine, the y, is 0. Well, isn't it 0 here and here? So it's pi 2 pi and 0. This one, this time the x is 0. So here on the unit circle and there. What angles are here and here? Pi/2 and 3 pi/2. This next one is a little bit 3. Because it's tan. And remember, tan is always y divide x. So which points on the unit circle, when I take its y value, divide its x value, I'll get 0. Let's look at this one. What point is this? What point is this? 1, 0. So the second one, 0, divide 1 is still 0. So that works. So 0 is an answer, and so is 2 pi. How about this one? Because I want to go to the ones where there's zeros. This one is 0, 1, right? But that's undefined if we divide it. So that's not an answer. If we go here, this is -1, 0. Second one, 0, divide -1 is 0. So yeah, pi is an answer. And if we go down here, we're going to get 0, -1. Well, -1 divided 0 is undefined. So that one doesn't work. So there's your answers. Why is it putting little dots here? How about this one? You all right? You okay? How you doing? You all right? Huh?
Okay.
You okay? Huh? Turning red.
I just get red. All these things.
I know. I'm just saying.
Yeah. Thanks. You're making me smile.
Oh, that's nice.
You know,
0 and pi and 2 pi, where cosine is 1. 0 and 2 pi is correct. What about where sine or y is -1?
you're fine with me.
3 pi over 2. This one you haven't seen before. It's not a unit circle value, so let's start with the calculator. Well, what quadrants? We're dealing with cosine, and it's a positive answer, 1 and 4. And then how do we find the reference angle? We take the inverse trig, in this case it's cos, of the positive value, 3. And what are you going to get? You are going to get an error. What? Why? Because you can't do it. It's impossible. If cosine or sine is bigger than 1, you will never be able to solve them, ever. So as soon as you get an error, no solution. Can't do it. Okay? Like if you try the sine of 2, the cosine of 4, even if it's past -1, the sine of -2, the cosine of -3, those will all be errors. What's that? Yes, if it's more than 1 or less than -1, right? Because -2 is less than -1. Why? Why? What? Okay. Let's look at these ones. We'll wrap up this first part of the lesson with these ones before we get into the sine squared and the cos squared and the tan squared, where you have to factor to solve, or you have to use the plus minus square root to solve. You have to take things that you have to take different things that you know to solve, but we'll worry about that Wednesday. Okay, this one, how do I get cos theta by itself? So subtract 1. Hello. Hello. You all right? Hit your elbow on the desk or something? So that was. Is that you again? No, it's you involved in. Unit circle value? Or calculated? Yeah, that's the unit circle. Where cos is negative a half. So cos is negative a half is up high here and down low here. 2 pi over 3 and 4 pi over 3. Here's our answers. This, I got some work to do. First of all, I got to bring the tan thetas together. So I'm going to subtract both sides by 7 tan theta. Those cancel out on the right. 3 tan theta minus 7 tan theta is negative 4 tan theta. And I still have a minus 5 on the left. But on the right, there's only negative 6. Now it kind of looks like the previous one. Add 5 to both sides, so you get negative 4 tan theta is equal to negative 1. Divide both sides by negative 4, and you get negative 1 divided negative 4, which is the same as positive 1 over 4. Unit circle or calculator? Calculator. 1/4 is not a point on the unit circle. So, quadrants, tan, positive. What quadrants is tan positive? 1, 3. And then I got to find the reference angle by doing the inverse trig. In this case, it's tan. The positive of whatever this is, it's already positive. And remember, we are asked in radians. Hey, I think I have radians. Yes. Every time I'm moving. So I got to do inverse tan of 1 over 4 in radians. Inverse tan 0.250, right? That's how you would round it. 3 decimal places. Now you take these 2 pieces of information and combine them into the answer. So in quadrant 1, theta, the actual angle, is going to be the same as the reference angle. That's one answer. In quadrant 3, how do I find the actual angle? 180 plus the reference angle, but we're in radians, so not 180, pi. That's going to give us 3 point something. 3.392. That's the resonance.
What is that?
What's that?
Why don't you do it?
Because remember, if we're in degrees, to find the angle in answer 3, it's always 180 plus the reference angle, right? But because radians, what's 180 in radians? That's pi. Oh boy. What's weird about this one? Well, square root is a little weird. What's weirder? We haven't solved one of these before. A cosecant. Okay. So first of all, let's do the same thing. Let's get cosecant by itself. So I subtract 2 from both sides. And then I divide both sides by the square root of 3. But I don't know how to do the reciprocal ones on the unit circle. I only know sine, cos, and tan. Oh. What does this flip to? So if I'm going to flip the left side of the equation, to keep it balanced, I'm going to flip the right side. Well done. Well, that's something I can solve. These two are going to have the same answers because they mean the same thing. And it's a unit circle value, even better. I'm going to use my calculator. So now I'm thinking, okay, sine y negative root 3 over 2. That would be down here. And it would also be down here. What angles are those? 4 pi over 3 and 5 pi over 3. And this. Well, first of all, let's get cotangent by itself first by dividing both sides by 2. I don't know how to solve cotangent, but if I do flip, cotangent flips to tan, which means I got to flip the other side. Calculator or UCD? Calculator. So I need my quadrants. Sorry? 2 and 4, because tan is negative. So quadrants 2 and 4. And then I got to find my reference angle by taking the inverse trig, in this case it's tan, of the positive value. So this is negative. To find its reference angle, I got to change it to positive. And remember, make sure you're still in radians. So inverse tan, 2 divided 3, 0.588. Okay. So now I can find my actual angles, which are in quadrants 2 and 4. How do I find an angle in quadrant 2? Pi minus the reference angle, Because remember, it's 180 minus the reference angle, but we're in radians, so it's pi. So pi minus 0.588, which gives us pi minus 0.588 should be 2.554 for rounding. Okay. And then in quadrant 4, well, normal in degrees it's 360 minus, but here it's 2 pi minus because we're in radians. You guys are getting the hang of it. Good. So 2 pi minus 0.588, 5.695. Yeah, I think I'll leave it at that for today. We might actually finish this Friday, because like I said, it's pretty big. So that basically review from last year, except we added radians on and we added reciprocal trig. Okay. So yeah, the next step is what about equations that look like this? What's different about these ones? They got squares in. How do we solve squared equations? We did it last year. We did the plus minus square root, or we factor. Okay, which is, we're going to do the exact same thing. But we'll leave that.